Hey everybody, today for class you will be watching a video. Before we get started, I wanted to let you know my office hours today will be from 2:30 until 3 o'clock. So if you need to come see me for some reason, make sure you come between those times, okay? Let's go ahead and get started. Today you will have a Google form to fill out. Um, so right now what I'd like you to do is pause the recording and go back into the module and click the Google form, which you will see right in the module 4.12. Okay? So make sure you're going there to find the Google form because you will need to submit it for your participation points today. Okay? And again, let me show you that you will see this little symbol. Do I have a little space? You will see this little symbol on every page that you need to answer a Google form question. Don't forget, I will review the answers, so all of your answers should be correct. So make sure that you wait, watch the video, and put your answers in as you go. So you want to open it right now, and then we'll get started. I obviously can't send you or put the Google form link on this page. You won't be able to access it that way. So you'll have to go into the module and get it that way. Okay, so today we're going to talk about 4.12, energy of convection. We talked briefly about convection yesterday. Did you complete your Unit 4 quiz? Get your quizzes submitted today if you haven't already. Remember, you have 2 attempts. So the earlier you get it submitted, then you have more time to study and then do your second attempt if needed. All right, student objective, you're going to explore the movement of convergent and divergence plates and subductions. All right, let's review from the last class. Let me move this here, over here. In the asthenosphere, plates move with the direction of the mantle. The temperature differences activate a convection current which starts the flow of fluid. The main cause of those convection currents are density and temperature. We talked about that briefly yesterday. And we talked, actually, this specific slide was in yesterday's class, and we'll talk a little bit more about convection. This is actually a slide from the first lesson, second lesson, in Unit 4. Okay, I wanted to put this on here so that you guys could remember, where can I put this where it's not hiding this? So that you guys could remember the information that we reviewed when we talked about the layers of the Earth. So remember the asthenosphere. Under the lithosphere is the other part of the upper mantle called the asthenosphere, made of rock that is almost at its melting point but not yet liquid. High temperatures and pressure cause this rock to actually flow, and it has plasticity. Remember we talked about that yesterday, meaning it can be molded. Think about clay and think about the consistency of clay. All right, so the asthenosphere is in the lower part of the upper mantle. Okay. We learn that plates on Earth's surface move, but how do they move? These plates are large and quite massive. Scientists believe that 2 forces are responsible. We talked about it yesterday. Do you guys remember? Convection and gravity are the 2 forces that are responsible for the plate movement. Okay, in this lesson, you're going to investigate how each of these forces is involved in plate movement. Okay, so hopefully you have your Google form open. Let me move this. Okay, who likes hot cocoa? This is your first question. Everybody should get this right, and this question is obviously based on you and if you like it. So there's no right or wrong answer here. Who likes hot cocoa? So you're going to enter this into your Google form. Green check means yes, I like it. Red X means no, I don't. All right, so we're going to start with a video. Is that really hot cocoa? Let's check it out. All right, so the video is also in your module. So at this point, if you would like to pause this video and go watch that video, you can, or you can watch all of the videos at the end. Okay, there are 2 forces behind the movement. Where am I going to put my picture? Convection is the movement of gases or liquids due to differing temperatures. We talked about that briefly yesterday. And gravity is the force of attraction between any 2 masses, such as Earth and everything on it, including giant tectonic plates. Okay, shifting plates. The Earth's crust is not a single piece. It is a series of tectonic plates. Anybody remember how many plates there are? I don't know if we actually talked about that specifically, but these plates are still shifting today, some moving further apart, others closer together, depending on where they are in relation to each other. So when Pangaea broke apart about 200 million years ago, large pieces of land shifted, eventually forming the arrangements of continents and oceans of today. You can see that the Earth's crust is not a single piece, but many separate pieces. Okay. Floating crust. I'm going to have to cover the ducky. Earth's plates rest on the asthenosphere. Okay, here's that same picture from before. Remember, it's made of molten rock so hot that it flows, and it's like a clay consistency. When convection causes currents in the asthenosphere, Earth's very large, very massive plates actually move around. Now, they move around very slowly, but they still move around, and over a long period of time, it makes a big difference. It's a little like a bathtub filled with floating bath toys, but it's slower and you don't notice the movement as easily. All right, so here is your second Google form question. Earth's tectonic plates are permanently in place. True or false? What do you think? Are they permanently in place? Here's where you'll want to pause, choose your answer. Okay, so the answer here, let me get my highlighter, would be false. Ooh, come on, false. Okay, because we know that Earth's tectonic plates are constantly moving. Okay, let's talk about the floating crust. Need to grab my pointer. All right. Okay, I'm sorry if it's covering part of this slide. So actually, I think hopefully that's hiding it. So while divergent plates move away, remember we talked about divergent plates yesterday, and when you think of divergent plates, think of dividing or moving apart. Okay, they move away from each other. Convergent plates, converging or coming together or colliding together. Okay, they collide with one another. Sometimes one plate slides under another in a motion called subduction. We also talked about subduction. Okay, so this right here, okay, this picture here is an example of conversion. Okay, this plate is sliding under this plate. This is an oceanic plate, but it's sliding under the continental plate. At other times, the plates will continue to push up against each other, folding and crumpling and sliding upward, creating mountains. The Himalayas, the highest and youngest mountains on Earth, formed at a convergent plate boundary. All right, here's another quick check. Subduction is when a plate slides under another plate. True or false? What do you think the answer is? This is where you would pause the recording, make your choice, and put it in your Google form. Okay, so subduction is when a plate slides under another plate. The answer here would be true. Make sure you put true in your Google form, or change it if you've put something different. All right, let's talk about, I think I'm going to have to hide this again. Let's talk about transferring heat. Heat flows from warm areas to cool. Some spots of the asthenosphere are cooler than other spots, and when these areas heat up, their density decreases and they rise. And eventually, these areas cool again, and the process continues. It results in a circular motion or a current, or what's called convection. Okay? Convection is also responsible for currents in the air. Think about when you see the weathermen talking about the currents in the air, okay? Hot air, a gas, rises near the equator and flows towards the poles where it cools, becomes denser, and then sinks. Okay, transferring heat. The cycle of convection in the mantle is shown with the yellow arrows. Okay, so let me get my pointer out. So here, okay, where these yellow arrows are, this is the cycle of convection, and we talked about this yesterday, okay? And if you think about it, if you have a solid and you've got a liquid underneath and the liquid is moving, that solid on top is also going to move. This process of convection is very slow, which causes the plates above them to move. Notice the asthenosphere in the upper portion of the mantle. The molten rock in this area are so hot that they flow like a fluid. Are you with me? All right. Where does convection occur? Okay, so you'll want to pause the recording, make your choice, and then turn it back on and I'll tell you the correct answer. Where does convection occur? The correct answer here would be, hold on a second here. Okay, the correct answer here would be, sorry, technical difficulties here. The correct answer would it be your mantle, inner core, or outer core? It would be your mantle, because remember that your asthenosphere is part of the lower part of your upper mantle. Okay, so Oreotectonics, it's movie time again. If you look on your module, you will find a video that's named Oreotectonics, and this is where you would watch that, or you can wait until the end of all the slides to do that. All right, let's rest those brains. Take a quick break if you need to. What should you eat for breakfast on Earth Day? Pangea cakes. And a day without laughter is a day wasted. At this point, if you need to take a quick break, press pause and return when you're ready. All right, gravity moves those plates too. Scientists believe that gravity is another important factor influencing plate movement. It can create ridge push and slab pull. We'll talk about that quickly here, but if you look, let me see if I can get my pointer again. If you look, here's where it says slab pull, here's where it says ridge push. All right, let's talk about ridge push. I think I'll hide my face again. Ridge push occurs at mid-ocean ridges, so right here, which are elevated higher than the rest of the ocean floor. Heat from rising magma pushes rocks upward from the ridge. As they cool, they become denser, and gravity acts on those raised edges, pulling them downward and away from one another. This creates room for more hot magma to well up at the ridge, forming new crust. Notice how the arrows in the picture slide downward along the raised ridge. Okay, they slide down here. All right, we're going to skip this. We're going to move on to slab pull. While gravity is pushing on one end of the thick plate, at the other end, cooler, denser crust sinks into the mantle. This pulls on the rest of the plate, creating slab pull. So look at the diagram. Gravity acting on the slab pulls these edges down, okay? And that's slab pull, so it moves them in that direction. Gravity is the force that activates ridge push and slab pull, exerting pressure on the edges of plates. In response to this gravitational pull, plates move. And then here's another thing that you can try, but we're going to skip that right now, and we'll talk about circulating crusts. Earth's crust moves because convection causes material in the mantle to flow, like we talked about before. Plates may move toward, away, and under one another, or continue to collide, fold, and crumble, resulting in mountains. Gravity pulls on plate edges, and creating ridge push and slab pull, and making room for new rock to form. Earth plates are in constant motion. The continents are constantly shifting their positions. And then we've got one last video. This is a really awesome video, so make sure that you take the time to watch this one. There's some review here. Make sure you know all of these terms: convection current, asthenosphere, slab pull, ridge push, ridge, and trench. Make sure you read through the lesson and complete all the activities. By the way, you may submit your Google form now.